Welcome to Virtual Pathfinder YouTube channel. In this video I will show how to image the blinking Planetary Nebula NGC 6826. First, let's have a look at it in the Stellarium app Sky Safari Pro on my iPad. It can be found by a search which leads to an information page from which it's possible to click an icon to show the object at the center of the screen. Here I split the screen to show the Stellarium map next to my image of the nebula. I zoom in to make them equal in size, but the photo is slightly rotated in comparison with the Stellarium star map. To look up the location of the object with a circle showing the telescope field of view is important to find the object unless you have a go-to mount. Before showing the resulting images of the nebula, I will show the equipment used. First we have the telescope, which is a Skywatcher EvoStar 72ED, which is an ED refractor, which means that it is fairly well color corrected. It has a 72mm aperture and 420mm focal length, which means that it is a bright telescope with aperture ratio f5.8. As you can see in the images on the Skywatcher's website, it is a small refractor. When doing deep sky astrophotography, it is valuable to have a bright telescope that has good light gathering capacity, since the deep sky objects are faint. Then we have the star tracker used to track the deep sky object, that is Vixen Polarie. It is a very compact product which works as a motor for an equatorial mount in portable format. It can be driven by 2 AA batteries or from a power bank. As you can see in the images from Vixen's website, it is a small white box which can fit in a large pocket of a jacket. I bought mine 6 years ago to be used with various lenses on my mirrorless camera. According to specifications, it was stated it can handle up to 2 kilos of load. I was surprised later to find out that it could actually handle a lot more than that, using a counterweight. I discovered the extreme usefulness of this piece of equipment when I saw the Vixen Polarie upgrade kit. The Vixen Polarie upgrade kit consists of several parts to be used together with the star tracker. Those parts enables the user to attach a counterweight bar to a holder on the rotating part of the motor. A counterweight can then be attached to the bar, which also has adjustable length. Apart from the counterweight bar, there is a tilt head to adjust the tilt angle of the axis of rotation to the latitude of the location of observation. With these parts, it's suddenly possible to load the star tracker with equipment up to 6.5 kilos weight, which means that it can handle a small to medium-sized telescope. I immediately wanted to have that kit, until I saw the price tag. As you can see on the web shop I found on the internet, it costs 679 British pounds, which is about $860 or euros. That is more than double the price of the star tracker itself, and in my opinion, it is overpriced. Think about it, the star tracker cost 420 euros. And then on top of that, the upgrade kit cost another 860 euros, which makes the total 1,280 euros or US dollars. That is way more than I'm prepared to pay. You can get a good astronomical go-to mount that can handle much more weight for less money than that. So in conclusion, I love the idea of being able to use this tiny tracker with a small to medium-sized telescope, but this kit is way too expensive. The solution to my dilemma was to create my own upgrade kit using various parts from the toolbox and mainly ordinary photography equipment. Since before I've used a stable tripod with a tilt head holding the star tracker. I replaced it with a tilt head which could handle a lot more weight, and then I had to solve the next problem. The star tracker is attached to using a 1/4-inch screw hole at the bottom of the star tracker with a heavy load that is risky since the star tracker with the load can start rotating around the screw. Therefore I attached it to a dovetail rail to which I added a clamp so that the star tracker cannot rotate. Those parts were from IKEA furniture and some screws from a lamp, and they have worked well for many years now. There is also a similar problem with the 1/4-inch screw on the motor axis of rotation. I used to have a ball head to hold the camera using that screw, but with the heavy load of a telescope, there is a risk that the telescope will start rotating around that screw. For that reason, I added a clamp, which by friction is held against the plate very firmly. That clamp can hold a longer dovetail bar, which can then hold a counterweight. It was a puzzle to find the right tripod heads and dovetail bars to actually make it possible to attach a telescope. But eventually all parts were added and I can use it for telescopes from 1.8 to 4.5 kilos. The heaviest payload including camera was about 6.5 kilos, but I have to admit that I didn't feel totally safe to push it that far. I love the compact design and the precision of this product. I have used it for very long exposures, up to 12 minutes. The capabilities of this star tracker has exceeded my expectations by light years. When I bought it, there weren't many other similar products, but now there are some options like the Skywatcher Star Adventurer. I haven't tried that one, so I cannot make a comparison. Here is the resulting image of the blinking Planetary Nebula. It is a single frame. If I had more time, I would have shot some more frames and stacked them to reduce noise. Still, I think it's quite okay, considering it is a single frame image shot by an ordinary mirrorless camera. Some facts about the blinking Planetary Nebula. It has apparent magnitude 8.8 and it is 27 × 24 arcseconds. It is estimated to be about 2,000 light years away. If you want to see a very detailed image, check out images shot by the Hubble Space Telescope of it. That was all for now. I hope you got some useful information or inspiration from this video. Remember to subscribe to this channel. I will make more videos about how to do astrophotography more affordable and more travel friendly. Until then, have a nice day and many starry nights.